Hi guys, Mr. Martin here again. Thanks so much for joining me. Now, today, looking at the second of our theories, the second model into memory, this time the working memory model. So remember, last time we looked at Atkinson and Shiffrin 1968, the multi-store model. This one, a little bit more elegant. It tries to account for some of the things that the multi-store cannot. So let's dive right in, and I'm going to give you a little task to do just to kind of prove why we need this model here. I want you to tell me how many windows you have in your house. Now, I would be very surprised if you knew that, because it's not really something that you're that interested in, right? You know you have windows in your house, but you can't tell me straight away. But I can almost guarantee I know what you're doing. You are taking a mental walk around your house. You have conjured up an image of your house inside your head, and you are walking from room to room, counting up the windows as you go. Now you'll get to the end, the last room in your house, and you'll tell me how many windows that you have. 21 or 35 or however many it is. Okay, good. Remember Atkinson and Shiffrin's model, the multi-store? They would tell us that that memory should be in your long-term memory already. You've processed it and you've stored it there. But hang on, none of you knew what or how many windows you had. And moreover, that memory didn't exist until it did. Whoa, mind trip, absolute mind blow here. Okay, so you have memories inside your head that you don't know until you know them. Now, Baddeley and Hitch are pointing out basically this logical fallacy. Obviously, the memory can't be as simple as that because you have problem-solving ability inside your mind as well. It's not as if you have all these memories neatly pre-packaged, ready to go. Some of them you have to work out. So what they develop in direct contrast to the multi-store is this model here, the working memory model. Baddeley and Hitch, 1974. We should start off by saying that this only really focuses in the short-term memory. It doesn't really focus on sensory or long-term. We'll talk about that later. So really, throughout all of this, we're focusing on the short-term memory. Now, Baddeley and Hitch reject the idea that the short-term is just a very small store, that information slowly passes through on its way into the long-term memory. They say, no way. Short-term memory is more than that. It can manipulate, it can move, it can change, it can flip things upside down, it can look at things from different angles, it can solve problems. So they would much rather view the short-term memory as an active processor. Give it a task to do and it will report back. It will churn it through and report back to you rather than just be a static, very passive store. Another way to think about this is that the short-term memory is your problem-solving part of your memory. It's the one that kind of synthesizes memories together and reports back. It's especially difficult tasks to do. So for example, if I ask you to solve a division problem, well, hang on a minute, with the multi-store model, I have to go in, I have to find the rules for division, I have to bring them back, then I have to apply the numbers. Nah, too complicated. This working memory model, that's where division would happen. It's all to do with the synthesis of memories. Now, what does it look like? Well, Baddeley and Hitch would report that the central executive, that's the most important part of the working memory model. This is where the problem comes in. Central executive is basically the boss. It says, right boys, we have some work to do. We've got a problem here. How many windows are in our house? Does anyone know? Nobody knows. Okay, let's work it out then. The central executive can rely on two slave systems down here. They're called slave systems because they have to do what the central executive says. You've got two of them, the phonological loop and the visual-spatial sketchpad. Now, easier way to think about this, inner ear and the inner eye. So let's go back to this problem again. We're taking a mental walk around our house. The sketchpad builds that image inside. It builds your house for you and it takes the walk for you. You're in the first room, you see the first window. You count one. This loop here repeats one back to itself. It keeps a tally. You are saying it to yourself. You go into the next room, you count two. There's two, two, two. Next room, there's two more windows. Four, four, four. And so on and so on and so on until these two come up with the correct answer. So whatever it was, to be honest, I don't really care how many windows you have in your house, but you've come up with the answer and the central executive has told you what that is. Active problem-solving processor. Very, very neat idea. What evidence do we have that the working memory model is correct here? The answer, we'd have lots of dual task performance evidence. If we're taking the idea that the working memory has two slave systems, well, what happens when we give it two things to do at once? What actually happens to how long it takes? So Baddeley and Hitch have a very neat idea here. What they do is they give participants a very simple logic puzzle. In this case, it's swapping letters back and forward and saying if things are true or false. It doesn't really matter what it is, but we've given the memory one thing to do. And then we give them another task, which varies in difficulty. The idea here is that we've given the slave system something to do, and we also give the central executive another problem to focus on at the same time, something not related to the study, but something to occupy its time. So for example, while the participants are trying to work out the logic puzzle, trying to move these letters around, they also have to repeat words to themselves. The. Or it might be counting upwards. 1, 2, 3, 4, 5. Or they might have to start repeating digits back. 6, 3, 2, 6, 3, 2, 6, 3, 2. What Baddeley and Hitch find here is that the more tasks or the more difficult tasks you give the working memory model to do, the longer it takes you to do them. Now, this makes sense only for the working memory model. If you give the mind a memory to try and solve something to process, and you also give it another task to do, it takes you much longer. Well, how do we account for that with the multi-store model? We can't really. Why should it take you longer if you've got two tasks to do instead of one? We have no idea. But with the working memory model, it makes perfect sense. Evaluation-wise though, guys, 12 participants. Really? Not many at all. How relevant is that to the rest of the world? Probably not much. And, well, think about the tasks that we're doing here. We're solving little puzzles and we're repeating digits back to ourselves. When on earth would you normally do that in real life? Unless you were a contestant on Countdown, I don't think you would have any real reason to do that. So, a nice little study nonetheless, but very, very limited in some ways. A little bit later on in the year 2000, Baddeley's asked to account for something that's missing here. He's asked, okay, so if I ask you to remember a specific time in your life, sounds and sights at the same time, where does that come from? Baddeley's thinking, that's a good question actually. It can't start here because that's just the vision. And it can't start here because that's just the sound. So what Baddeley adds to his diagram is this third slave system in the middle. This he calls the episodic buffer. This, if you like, is where everything is glued together. So, for example, if I ask you to remember the last time you had, the last time you went out for a meal, how's about that? Well, instantly you recall where, when, what was happening when you were having that meal. This is the sight. These are the sounds. It's all glued together in the episodic buffer, that episode of your life, and you report it back via the central executive. Important to realize here, the working memory model, it's not static like the multi-store is. It's constantly changing, evolving, improving over time. Very, very interesting. In terms of evaluation, I'm not quite sure why the multi-store is there. Sorry about that, guys. In terms of evaluation, one of the positives we can mention is that this is very well supported, especially by dual task techniques. The multi-store model cannot account for why it takes longer if you've got more than one thing to do, but this can. There are lots of other bits of evidence as well, but these are the ones to focus on for the exam. Second thing, it has a lot of practical applications. For example, people with dyslexia tend to have issues with either viewing the words literally dance on the page to them, or the processing of words. They can see the words fine, but they don't understand them, or they get things wrong, or something's happening with the actual processing of that word. So what this means then is there's either a problem here, at least according to Baddeley and Hitch, with either the visuospatial sketchpad, that's the words actually not being seen properly, or with the phonological loop, that's the words being seen fine, but you've processed them wrong. You haven't heard, in inverted commas, heard them right inside your head. So if we know which one of those two it is, we can target our therapy for this dyslexia. We can make things better for them based on the working memory model. Quite interesting. In terms of weaknesses here, the central executive remains, to this day, relatively unexplored. What actually is the central executive? What does it do? And how much power does it have? And how does it work? And is there more than one? And does it have any memory of its own? We simply don't know. It's very difficult to test that as well. So it's one of the biggest parts of the system. It's also one of the least explored. Second thing is it's very difficult to falsify. If you get something wrong, well, that makes sense, right? That's your central executive being overloaded, or it's the slave systems having too much to do. If you get something right, well, that means the working memory model is working perfectly. Well, hang on there. Well, how do we falsify this then? How do we prove that the working memory model might not be the right model? Turns out we can't actually, and that's, remember, frowned upon in psychology. If it's difficult to falsify, we don't like it. We like having a way out. And lastly, it only really focuses on the short-term memory. Doesn't explore long-term, doesn't explain how that works, doesn't explain how sensory memory works either, only focuses on short-term memory. So that leaves out two huge parts of memory that we would rather have a look at as well. Key concepts here, and there's quite a few of them, guys. Central exec, slave systems, of which there are two. The third one, the episodic buffer, you can add in as well for extra marks. Multitasking is the whole point of this and supported by dual task studies. If you can remember these 6 things here, you're off to an absolute winner. These are the kind of things to be looking at. Okay, guys, that's it again for another episode. Thanks again so much for joining me. Next lesson, we'll be looking at the specifics of how we can apply memory to the real world. This is in terms of eyewitness testimony. Thanks a lot, guys. Cheers for listening, and we'll see you later. Cheers!